Okay, welcome back for this last part. Now again we will discuss some problem. We are discussing some questions. Okay, the sixth question: if the longest wavelength in UV region of hydrogen spectrum, that is lambda naught, then the shortest wavelength in IR region. Okay, options are 46/7 times lambda naught, 20/3 times of lambda naught, 36/5 times of lambda naught, 27/4 times of lambda naught. Okay, longest wavelength they have asked. Longest wavelength UV region. UV region means essentially it's a Lemon series, because we know that Lemon series basically lies in the UV region. So now the formula is same, lambda naught R into, for Lemon series it is actually 1/1 square minus 1/n square. Now the longest wavelength means the shortest energy, right? Shortest energy should be 2 square. So it is 1 by lambda naught. So that means it is actually 3/4. So lambda naught we have find that 4/3R. Okay. Now we have to find out the shortest wavelength IR region. Okay. UV Lemon we know, then the Balmer is also invisible, right? Then Lemon, Balmer, Passion, these series are there, right? But okay, they have asked for the IR region, that is important. IR region and the shortest wavelength of the IR region. Okay, means you understand this is the UV region, then the visible region, and then the IR region. Shortest wavelength of the IR region should be the that means the highest transition should be there. So that should be, it's actually Balmer, then it should be Passion, because it's the IR region. So it should be Passion's it's IR region. So then for that 1 by lambda should be R into 3 square minus n square, but you need the shortest wavelength, that means the higher energy gap, that means it should be again infinity, just like the previous problem we did here similarly. Okay, one thing you should understand, that let us say this is n equals to 3, if it comes from n equal to 4, there that also lies in the IR region, that is also Passion series. If it is n equals to 4, 5 to 3, 6 to 3, 7 to 3, but when it's come from the infinity, that means that is the higher energy gap. You may also ask after that Passion, Fund or Bracket, these series are also lies in the IR region, but that wavelength will be greater, that energy gap will be shorter, because for it is n equals to 4, let us say coming infinity from 4 or infinity from 3, is obviously the energy gap for infinity to 3 will be larger compared to any other cases. So this should be the shortest wavelength. So it is actually R by 9. So now we have to just put what is the R here. R is actually 4/3 lambda naught. It's then R 4/27 lambda naught. So lambda will be 27/4 lambda naught. So this will be the correct option, D. Okay. Now what will be the question number? It's 7. It's again an interesting question, I guess. It's easy but some different kind. Some energy levels are shown. How? it's like this. This is minus E, this is 4 by 3 E, 2E, and so on. Not up to the scale, but this is. There are two transitions are there. This one is corresponding wavelength is lambda 2, this is lambda 1. Then they have asked the ratio of the wavelengths. It's easy question, just lambda 1 divided by lambda 2 they have asked. Okay. So what will be that? What is the lambda 1? Lambda 1 is related to the energy gap. How? That del E is, we know, hc by lambda. So del E1 should be hc by lambda 1. It is actually, what is the energy gap? That minus E minus 4 by 3 E. So it's actually 4 by 3 E minus E. Eventually it's E by 3. Okay. Similarly, it's lambda 2. So again it will be E minus 2E. Okay. So it's actually E minus or minus 2E. So it's E. So R is equal to lambda 1 divided by lambda 2. So it's essentially E2 divided by E1, del E2 because it's inversely proportional, you can see here. So it's E by 3. So it's essentially B. Okay, lambda 1 is actually this. Okay. 1 minute. Lambda 1 is this. So let me change it. So just you have lambda 2 divided by lambda 1. Then it's consistent with the question. Now it's correct. So they have asked lambda 2 divided by lambda 1. Then it will be del E1 divided by del E2. So it's actually E by 3 divided by E. So it's 1 by 3. So essentially the ratio will be 1:3. So it's an easy question, but it's showcased differently. Okay. So now again the question number will be, I guess, 8. Question is asked that an electron, this is very important question and probably this will be the last question. Then we'll, okay, let me first do it. Electron from various excited state of hydrogen atom emits radiation to come to the ground state. Yes, we know that. Let lambda n and lambda g be the de Broglie wavelength of the electron in the nth state and the ground state. Okay. Respectively. Let lambda n be the wavelength of the emitted photon in the transition from the nth state to the ground state. Okay. Then ask that for large n, what relation would be true? A is lambda n square equals to, not equals to, approximately equals to a plus b small lambda n square, b is lambda n square more or less equals to lambda, c is lambda n square equals to more or less a plus b divided by lambda n square, and the d lambda n square more or less equals to a plus b lambda n. Okay. So, let me first read it again. An electron from various excited state of hydrogen atom emit radiation to come to the ground state. Okay. Let lambda n and lambda g be the de Broglie wavelength of the electron in the n state. Okay. That is given, de Broglie wavelength, and the ground state. Okay. Let lambda n be the wavelength of the emitted photon in the transition from the n state to the ground state. Excellent. Means let us say two states are there, it's n, it's g, one electron is there, one electron, if it's come to that, then we know that lambda n, it should be related with the daily, right? Daily. How? Daily is actually En minus Eg, and then we know that daily equals, should be equals to Hc by lambda n, correct? A, B are the constant in this question. Okay. So, daily is this, that means equals to En minus Eg. That is not important. Also important is that the de Broglie wavelength, we have to find out the En and Eg, what will be that? En and Eg we have to find out, then we can do these things. Okay. So, what the de Broglie wavelength? We know that de Broglie said H by P means the MV equals to lambda. If the de Broglie wavelength is lambda, then what was the relation? If you remember, E equals to mc square, you know, E equals to h nu, you know, then it will be mc square, means equate these two for any thing, then it is actually P into C, it is actually P into C, you can write it P into C, and it is again C by lambda, then H by P equals to lambda. Yes. So, it is correct. So, H by P equals to lambda, this is the de Broglie relation. Okay. So, that lambda is given, but we need the this is from lambda and H we can find out that P should be equals to H by lambda, but we need the, not P, P is the momentum, but we need the energy, total energy. So, that should be equals to P into C. From that also we can do, right? Now, that is given, what is given? Yes. Okay. Lambda n and lambda g, that's are the de Broglie wavelength. We have to convert that because we need that En and Eg, then we can divide it, and from that we can find out the relation of lambda n, that we can do, but we have to do that first, that scale h square by 2 m lambda g. Kn and k, these are given. Okay, okay, k is h square by, okay, let us do what we can do. P means the momentum, but we know that kinetic energy Ek is half mv square, right? So, we can write it P square by 2m. So, it is h square by 2m lambda square, we can write it, right? Again we know that total energy Et and Ek are just related to the negative sign. This problem we have already done. So, if it is, then it will be h square divided by 2m lambda square. So, what will be the En, the energy of excited state? It will be h square divided by 2m lambda n square. And what will be the Eg? Energy of the ground state, it h square divided by 2m lambda g square. So, En minus Eg, it should be if you common it, these things lambda n square minus lambda g square. Okay, but we need in terms of, if you look at the question, in all question there is lambda n, it's even, it should be lambda n. Okay, so now for that what we can do, we can write it like this, lambda n square, then you can write it 1 minus, if you common it, 1 minus lambda n square divided by lambda g square. Okay, now they have asked this for the large n. Okay, that will come, but what was that? Del E equals to En, these things was there. Okay, so what we can write, this is our, what was the relation? Yes, this is the relation, h square divided by 2m lambda n square 1 minus something is this. Okay, let me write it, then we will see. So hc by lambda n is h square by 2m 1 minus lambda g square minus 1 lambda n square. If you look, just this formula again we have written, so there will be no any minus sign. So from here what we can write it, what we can write, if you take the LCM, then it will be lambda g square lambda n square, and it should be lambda n square minus lambda g square. So lambda n should be, h will be cancelled, it will be 2m divided by h, 2m divided by h, and c will be there, and this will be again flipped up. So it lambda g square lambda n square divided by lambda n square minus lambda g square. Yes, this correct. So now from here what we can write, mc divided by h, lambda g square is common, then it will be lambda n square divided by lambda n square minus lambda g square. Okay, so we can write it. So it should be 2mc divided by h lambda g square. If you divided it, then it will be 1 divided by 1 minus lambda g square divided by lambda n square, these things. So we can write it just inverse. For the large value of n, what we can approximate that, this value for the large value of m, so we can write it lambda g square, it should be 1 plus lambda g square divided by lambda n square. This is the approximation. 1 minus x to the power minus 1 is approximately 1 plus x for the very small value of x. Okay, so this approximation we have to do, otherwise we can't do this type of problems. Now we can write it equals to 2mc lambda g square divided by h plus 2mc lambda g to the power 4 divided by h into 1 by lambdas n square. Okay, so it can be written as a plus b into 1 by lambda n square, where this is the a and this is the b. So now if you compare, this is lambda n, so this should be the correct option, a plus, yes, equals to this lambda n square. Yes, this is the correct option, and lambda n equals to, not lambda n square equals to, this is lambda n equals to. Okay, so this should be the correct option. So this problem was very tricky. So let me stop here. So I think lots of numerical problems also we have covered. Syllabus already we have covered, we have already discussed the summary part, and various numerical question, types of question we have already solved in last two classes, in last class and today's class. So in this I think nothing to do for this part. So overall this chapter, the atom, is I think totally the syllabus and the numerical part all are the covered. So thank you for learning from me, and we'll again meet for the next class and for other chapters. So thank you for hearing me. Thank you.